So, good day, students. Welcome back to Scholars Universal Secondary School online physics class. So, last week we started with reflection of light and we talked about a few things. And I said we'll be continuing from reflection of light on plane surfaces today. So, let's move directly into the topic. So, reflection, the definition can be defined as the bouncing back of a wave when it hits an obstacle or an opaque object when in terms of light. Now, we have different types of waves, but for the meantime, we're only talking about light waves. You must have definitely learned about waves in the previous topics that you've been treated with. So reflection, like I said, is meant as a bouncing back. When something bounces back, the first thing that should come to your mind, an example, let's say you throw a tennis ball at a wall. Now, when you throw that ball and it hits the wall, what happens? It's going to bounce back to you, which means that what it has gone and it has come back towards your direction. When I'm talking about reflection, it says bouncing back of a wave. Now we're talking about light. That means when you pass a ray of light and it hits an opaque object, it's going to do what? It's going to bounce back towards the direction where it was first cast onto that opaque object. And that is what? Reflection. Now we're talking about reflection as plane surfaces, right? Which are now termed here as what? Planar reflection. So we have two types of planar reflection. We have regular reflection and we have irregular reflection. Now from here you can see regular reflection is when reflection of light is on a smooth surface. That means the light ray that is to be reflected was incident on a what? On a smooth surface. But irregular reflection is reflection of light when the light ray was incident on what? On a rough surface or a wavy surface. So let's quickly look at what this looks like. So you can see it's an example of regular reflection. The rays here were intended or incident on this smooth surface here. Usually we use a mirror for regular reflection. So let's assume this is a mirror. So the light rays have been incident on this mirror and they have now been reflected. They have bounced back in this direction. You can see the direction was from the upper side, and when the light rays were reflected, they are moving towards that upper side just in an opposite direction. You understand? So for the irregular reflection, you can see this is not a smooth surface, this is now a rough surface. And you can see when the parallel beam was incident on this rough surface, instead of being parallel, forming another parallel beam being reflected smoothly, you can see this one is now giving in different directions. So they are now forming another parallel line again. So let's move on. Let's move to the laws of reflection of light. Now, basically, we have just two laws of reflection. So the first one is the incident ray, reflected ray, and the normal all lie in the same plane. So now you might be wondering what is incident ray, what is reflected ray. Now let me show you what that is. Now you can see this diagram where you have a ray incident on a mirror. Now this ray incident on this mirror has been reflected to give this, right? Now the ray that is first hitting the mirror is what you refer to as what? The incident ray. Now why the final ray that is given off after the reflection is given noted as what? The reflected ray. Now there is an imaginary line that is drawn perpendicular to the surface of the mirror or to the surface of the reflector you are using, which is known as what? As the normal. The normal is what? Is an imaginary line perpendicular to the reflector or reflecting surface you are using, which is our mirror. Now you can see from here the angle between the incident ray and the normal is known as what? The angle of incidence. And the angle between the normal and the reflected ray is what? The angle of reflection. So let's go back to the second law. Second law says that the angle of incidence is equal to the angle of reflection. Now, if you are saying the angle of incidence equals to angle of reflection, that means from here what you have noted as your I must be equal to what has been noted as your R, and that's what you have with this over here. So coming back, note that these laws will only work for the reflection of light at plane surfaces. They will only work for reflection of light at what? At plane surfaces. When you have rough surfaces or you have wavy surfaces, this will differ. They only work at what? At plane surfaces, in fact, smooth plane surfaces. So I think that should do that. Let's move on. So let's go to properties of images. So now you can have different ways of getting the properties of images, but I'll be prescribing one which is very, very effective to you, which I have termed lost. Now when you know, you can surely remember that that is lost. Now each letter of this acronym lost stands for one thing or the other. Now L stands for location, O stands for orientation, S stands for size, and T stands for type. Now, when you talk about location, location describes the way the image is standing with respect to the mirror. Now, the location can be telling you about the distance of the image from the mirror, and it can also be telling you if the image is formed in front of the mirror or behind the mirror. I get me now. Images can be formed in front of the mirror or behind the mirror. Now note, if images are formed in front of the mirror, they are regarded as what? As real images. If images are formed in front of the mirror, they are regarded as what? Real images. But if they are formed behind the mirror means they are not formed on the screen, meaning what? They are virtual images. Now, another definition of real images can be images that can be caught on a screen. Images that are what? That can be caught on a screen. But any image that cannot be caught on a screen is regarded to as what? As a virtual image, which is what? Behind the mirror. Now, talking about orientation, orientation describes the way the image looks with respect to the orientation, with the object rather. With respect to the object, the way the image stands will give you what? The orientation. Orientation can either be erect, it can be inverted, or it can be both. And I will give you situations where you can have both of them together very soon. So let's move to the third one, which is size. So the size describes how bigger or how smaller the size of the image is with respect to what? To the object. So you can have either to be magnified, they can be the same. That means if it is magnified, it means what? The image is bigger than the object. It is larger than the object. But if it's the same, you know they are the same thing. And if it is diminished, it means the image is smaller than the object. So now let's move to type. So the type describes the nature of the image, like I have explained. It can either be what? It can either be real or virtual, which means real in front of the mirror, while virtual behind the mirror. So now let's use that to now get the properties of images that be formed by the plane mirror. Now for a plane mirror, you have the properties given by this. The image is going to be formed behind the mirror. So if you look at this now, you have this object here, this candle here, and it's being cast on this plane mirror. As you can see, an observer's eye is here looking at the image. Now the rays of this object, which is the candle, passing on this have now been reflected. But notice that the image is not formed in front of the mirror, which is at the left hand side. The image is formed what? At the back of the mirror, which is behind the mirror at the right hand side. So which means what? The image formed is going to be what? Behind the mirror, which means it is a virtual image. Now you can also see from here that the size of the image is exactly the same thing with the size of the object. You can see the height is the same and even the distance will almost be the same thing, equal. Let's go back. That means our location is what? The image is behind the mirror and is also what? At an equal distance as the object is from the mirror. Then the orientation. Remember, orientation is the way it is standing. So let's check that. You can see the candle, when you view the candle, which is the object, the candle flame is at the top while the base is at the bottom. Now looking at the image, exactly the same thing. The candle flame is still remaining at the top and the base is still remaining at the bottom. So that means what? The orientation means the image is erect, meaning it is standing exactly the same way as the object. Now for the size, you already know it's the same size as the object, and the type I've already explained. Since it's behind the mirror, it means that it is what? It is virtual. So note that in this orientation that is here, it was given that it is erect but laterally inverted. Now what does lateral inversion mean? Lateral inversion means that it looks almost the same, but it is like in the reverse direction. Now you can see this, let's say this is a student standing in front of a mirror. In the object, which is a student here, he was putting out his right hand. But when the image was later formed by the mirror, you can see it was his left hand that was being put out. Meaning what? It has been laterally inverted. You can try something at home. You can write, like say, the letters of the word HELL or any other word that you can think of. Write them boldly on a piece of paper and place them in front of a mirror. Now when you check the image that will be formed by that mirror, you will notice that it is looking like as if you are writing the letters that you've written from the back. That is what lateral inversion means. So let's move on. So now we can also have mirrors to be inclined at angles. Now when you now incline two mirrors together at an angle and then you view an object as an observer, you view an object in front of them, you observe that you have multiple images to be formed. Now the number of images that will be formed now has to depend on the angle at which you have inclined those two mirrors. If you have inclined them at an angle of 30 degrees, 60 degrees, 80 degrees, at different angles, they will have what? Different number of images. Now the number of images they will be forming is given denoted by the formula n equals to 360 over a minus 1. Now this formula will only work if 360 over a gives you an integer. For example, if you have angle 30 degrees, 360 divided by 30 will give you 12, which means what? 360 over a is an integer. That means this formula will work for inclining at angle 30 degrees. But imagine you are having to be inclining them at an angle of 70 degrees. If you have 360 divided by 70, it is not going to give you an integer, it's going to give you a fraction. A what? An improper fraction or a mixed fraction. Meaning 360 over a in that case is not an integer. So that's, if you incline at an angle of 70 degrees, you cannot calculate the exact number of images that you can get. Now note, n here denotes what? Number of images that you can see here, and a denotes the angle of inclination. So let's move on. So this is an example of when you incline two mirrors at an angle of 90 degrees. Now you can see here you have an object placed in front of them. This is the object. Now when you can now view the, as an observer, if you view the images in the mirror, you can see you are having what? Three different images. Now let's go back to our formula and check if this is correct according to the formula. Now if you're having what? 90 degrees. Now if you come here, you have what? N equals 360 over a minus 1. That's 360 over 90. That will give you 4. Then 4 minus 1 will give you what? 3. Which means what? The diagram here is satisfying the what? The relation that we have given. You can also see this is just a black and white form, while this here is giving a real diagrammatic form of what I've just explained. Let's move to angle 180 degrees. Now if you incline two mirrors at an angle of 180 degrees, you can see this point of intersection here, which is this red point. It means this is a mirror and this is what? Representing another mirror. If you place them at an angle of 180 degrees, they will just stand together and be forming a single mirror, since there is no angle that is like separating them. So they will just stand together and form just what? Just one single mirror. So you just be viewing how many images. Use your relation. You have 360 divided by 180, that's what? 2, then minus 1, giving you just one image. Now you need to check, if you view your image in just one mirror, how many images do you have? You have just one image. So let's move on to inclination at angle 0. Now you might notice that I skipped 270 degrees and 360 degrees, which you must have been expecting for me to talk about. Now try your 270 degrees with the formula. You have 360 divided by 270. It's going to be giving you a fraction and not an integer. Meaning that what? You cannot calculate the exact number of images that can be formed when you incline mirrors at an angle of what? 270 degrees. What about if you have 360 degrees? Divide 360 by 360, you have what? 1. Now 1 minus 1 is going to give you 0. Now imagine you are having a mirror, standing in front of a mirror, and you are not having any image produced. What does that mean? That means if you are inclining mirrors at an angle of 360 to each other, they have been placed upon each other. The surfaces that are supposed to view images from have been placed exactly on one another, meaning you cannot view what? Any image. So let's come back to what we're talking about, which is inclination at an angle of 0 degrees. Now, you can see this here. Before you can view these other images at the back, it must mean that there is another mirror that is exactly parallel and opposite to this mirror that this girl is sitting down in front of. Now if you now have that situation, it means there is no angle between both of them. They are what? They are parallel. No angle between them. That is angle what? 0 degrees. Now if you have that, you can see, you can keep seeing lots and lots of images that are being repeated, the same image being repeated over and over and over again, which gives you what? You have infinite number of images. Now check your relation. If you have 360 divided by 0, it's going to give you what? Infinity. Now if you remove just 1 from infinity, infinity means a number that cannot be estimated, that you don't know the exact value. Now just remove just integer 1 from that. It's still giving you nearly infinity. So it's the same thing as having what? Infinity. So if you have two mirrors inclined at an angle of 0 degrees, or you can say if you have two mirrors that are face parallel to one another and opposite, you'll be having what? Infinite number of images. So let's move on. Now we're talking about effect of mirror rotation on a reflected ray. Now, if you have a ray of light incident on a mirror and you keep that incident ray constant, that means you do not shake the direction of the ray, but then you rotate the mirror through an angle. Now you will notice that the initial reflected ray, when the mirror was still normal, we found to have been rotated to an angle which is equal to twice the angle that you rotated the mirror through. Now, let's check what I'm talking about. Now, you can see in this diagram here, the mirror was initially as what? A1, B1. That was the initial position of the mirror. So at that point in time, the angle of incidence, remember, is what? The angle between the incident ray and the normal. So the normal at that point was what? N1. Note that the angle of incidence here is what? Is still I. That means it is not changing for both situations. Now that means the angle of incidence then was what? I, and the angle of reflection was what? R. Now you know your I is equal to R, you can still remember that. So now moving to after the mirror has been rotated through an angle of what? Theta, which is here. You now have what? The mirror has a position of what? A2, B2. Then your normal has been shifted to what? N2 here. Now you will see from here that the new incident angle between this incident ray and what? And the new normal is going to be giving what? I plus the angle at which that mirror has been rotated, which will be the difference between the angle between the new normal and the initial normal. So the new incident angle will now be giving you what? I plus theta, and the new reflected angle will be giving you what? R plus theta. Now from here, initially we had the total angle of incident and reflected to be giving what? I plus R, right? Now the total angle after you have now rotated that mirror will now be giving what? I plus theta plus R plus theta, giving you what? I plus R plus 2 theta. Now you can now see also that when you are talking about it, you are looking for the difference between the two angles of the reflected ray. Now initially everything was what? I plus R. So if you now add the difference, that's the distance between the two reflected rays, it will now be giving you what? The new sum total. That means you have your what? I plus R plus D as I've given there. It's because what? The new total, which is what? I plus R plus 2 theta, giving us that our what? Our D is 2 theta, meaning the angle at which the reflected ray has been rotated through is equal to what? 2 theta, which is equal to what? Twice the angle at which the mirror was rotated. So you can see now that the log we have stated here is what? Is corresponding. Now, this phenomenon now is used in the working principle of the mirror galvanometer. So the mirror galvanometer is a type of device that is used to measure very small electric current using the use of plane mirrors. So moving on, I'll be talking about applications of plane mirrors. So the first one I'll be talking about is the kaleidoscope. The kaleidoscope is an instrument that consists of a tube. You have two plane mirrors inclined to each other. What we're talking about was inclination of mirrors. Now these two mirrors will now be inclined at an angle of 60 degrees. From here you can see the two mirrors inclined. This is the first mirror and this is the second mirror. The angle of inclination between them, which is this, is going to be giving what? 60 degrees. Now inside that tube you now pour different maybe pebbles or ground glass, different pieces of colored glass to form different colors. Now it is mostly used as toys for children. Now you have a viewing aperture here where you can view images from. Now you notice that when you shake the glass, the pebbles will form a kind of pattern which when viewed from this viewing aperture, you can see a pattern. Then when you shake again, you see another pattern. These patterns are mostly colorful and they tend to amuse children. That is why it is used as what? As a children's toy. So now you can see this little girl looking into a kaleidoscope, which she has already her pebbles, and the kind of image which you will see is what you can have here to the right of the arrow. Now you can even see from the face of the girl that she's even smiling, meaning she's happy looking at the colors. So let's move on. The second one I'm talking about is what? Is a periscope. Now a periscope is an instrument that consists of two parallel plane mirrors. These parallel plane mirrors are not as close as the one in the kaleidoscope. Now you also have like a tube, but you can see from here that the tube has like three legs instead of the normal one that was just two. So now a mirror is placed at this point at an angle of 45 degrees to the vertical or to the horizontal, whichever works for you, and the other one is placed to face the mirror the same angle of 45 degrees. Now what happens is when a ray of light strikes from this point and enters into the tube and it hits the mirror at this point, it is going to be reflected at the same angle, 45 degrees. Remember, angle of incidence equals what? Angle of reflection. So if it is reflected through an angle of 45 degrees, remember your total angle will be what? I plus R from the last relation. The total angle will be what? I plus R, giving 45 plus 45, giving you what? 90 degrees. So it's going to come directly straight down and it's going to hit the second mirror here. Now when it is, the same thing happens and it is then reflected to where your eye will be placed. Now this periscope is used in different things. You use it, soldiers use it for their armor tanks to view above the armor tank. Now, a soldier that is in the armor tank can see whatever is going on around and can know wherever to focus the gun to shoot. And it is also used in the use of what? A submarine. And I also watch submarines underwater. You can use to see what is happening above the water level through the use of periscopes. I can see this as an example. So let's move on. So these are some exercises that you can treat. So you had to differentiate between regular and irregular reflection. You state the laws of reflection. Then you state if the path of light is reversible or not. You are just to state if the path of light is reversible or not. Then you have to describe the loss of a plane mirror. Remember, loss stands for location, orientation, size, and type, which is what properties of images formed by what mirrors. Then you are also to describe the loss of a pinhole camera. Then you have to differentiate between real and virtual images. So that should be all for this class. So we'll meet in the next class.